So I forgot to record, so let me back up here. So again, we're looking for this equation. We have this function, and I want it to be parallel to this line. I rearrange the equation of the line to get the slope, and there's my slope, -1/2. Second thing I need now, I found my slope. Now I need to find the derivative. Find f prime. So I know my derivative is f prime of x. That was our little notation. Talked about our notation here. F prime of x was the limit as h approaches 0 of f of x plus h minus f of x over h. And I'm going to put these in brackets. I plug in my x plus h to the equation minus my regular equation. So I'm going to take this x plus h and I'm going to put it into the x. So I get 1 over square root x plus h minus 1 over square root x over h. So this is kind of a messy situation. I got a fraction and these radicals. What do I do? This fraction radical situation. I know that I have to I probably have to do both the conjugate and the making things the same fraction. Conjugates first, maybe. Maybe if I do conjugates first, we can try that. This would be 1 over radical x plus h plus 1 over radical x on the bottom. Radical x plus h plus 1 over radical x. If we do the conjugates, let's see what happens. When I do my distribution, right, I really only need to multiply, again, the first piece and the last piece together. First piece is multiplied makes this going to be limit of h approaches 0 of 1 over x plus h. Right? Because if I multiply these two fractions, the top part multiplies together. 1 times 1 is 1. Bottom times bottom is x plus h. That's rather nice. And this is going to be 1 over x. Seems great. H times 1 over radical x plus h plus 1 over radical x. My bottom part's going to be kind of ugly still. But the top part conjugate, that worked out really nicely. Now I can have an easier time of making this fractions into one big fraction. Right? I'm going to cross multiply. Not really cross multiply. I'm going to give each side the parts they're missing. This is x plus h here and x plus h on the bottom. Call this crisscross applesauce, right? Make the denominators the same. Give each piece the part they're missing. So this whole x plus h piece I need to give to the fraction here. And the whole x here I give to this fraction here. So I give each piece the part that it's missing. The whole thing on the bottom I give to the top and bottom here. And the whole piece to the other side. It's an h. It's an h, everybody. So what's that going to be? We have limit as h approaches 0 of x minus x plus h over x times x plus h over h times 1 over radical x plus h plus 1 over radical x. Right, so this top one, I just combined the top parts. I know this was going to be x on the top. This is x plus h on the top. I know it was a subtraction, so I put those two together on the top, divided by the bottom parts, just multiply together. And the whole thing divided by this bottom part. Keeping track of these fractions, keeping track of this situation. So the top part here, if I distribute that negative, it's going to be negative x minus h, and those x's go away. Okay, let's see. What can I have? Negative h over x times x plus h over h times 1 over radical. So it's a big ugly fraction plus 1 over radical x. What can I do now? Well, I know if I do the flippy-do process here, this bottom part's already a kind of ugly fraction, so I don't really want to do the flipping. I don't really want to do that because this bottom part's already a real ugly fraction. But what I can do is I already know this h up here and this h down here are going to cancel. This is a numerator h and a numerator, like a denominator down here, right? So you could write this, yeah, I don't know. I don't know how you would write this exactly. Maybe this fraction here together, and then, yeah, I don't know. It's kind of real ugly. Real ugly mess. We could try to combine this fraction together here, right? Multiply both pieces, make this one fraction, then I could do the flip, right? I could do the common denominators here, give this a radical x, and give this a radical x plus h. Right? There's all these tools we have, everybody, right? And this is what I'm saying about practicing with these tools, getting these ideas, getting this, seeing the pattern, seeing these things happen over and over again, right? It's the same kind of thing over and over again. Oh, you have a fraction? Well, let's make a common denominator. Oh, we have a radical? Let's do conjugates here. This fraction, I could try to add these together, maybe, and then I have one big fraction that I can flip. I know that this is going to cancel, though. I know those h's are going to cancel. I probably have to do this fraction anyway. Let's see what I'm going to have. 1 over x times x plus h over, if I just left this alone, 1 over radical x plus h plus 1 over radical x. And the limit as h approaches 0 of that. As long as I got rid of this h, I think everything's going to be okay without doing the fraction combining, without doing this fraction combining. Maybe I don't need to do this. Because if I plug in the 0 for h now, that h is going to go away and that h is going to go away. And so I'm going to have 1 over x times x is x squared over 1 over, this is square root x, and 1 over root x plus 1, oh, negative 1. Thank you. Negative, negative, negative. Negative 1. Negative h, thank you. Negative 1. Negative 1 over x squared, right? Because this is x times x, because the h is gone. And this is radical x plus radical x. This is going to be 2 radical x on the bottom. I have 1 over square root of x plus 1 over square root of x. That's 2 over square root of x, right? Now I have my beautiful little fractions. Now I can do the flipping and multiplying. So I'm going to have negative 1 over x squared times radical x over 2. So it's going to be negative radical x over 2x squared. Ooh, kind of a weird function. That is my derivative. Okay. Kind of a interesting equation. Square root of x, negative square root of x over x, 2x squared. Coming from when we added these two bottom radicals together, got 2 radical x, 2 over radical x. Our h's canceled. We have negative 1 over x squared. I did my flipping, multiplying, and I have this as my derivative. Now we want to know when that is equal to our slope of negative 1/2. We want to know when this is equal to negative 1/2. So we're going to have to do some solving here. Negative radical x over 2x squared has to equal negative 1/2. Make it equal to the slope. Make f prime equal to the slope. And solve. And solve. This has got a bunch of x's. I need to get my x's. Like, how do I solve? This is a a weird looking function. How do I solve this? Well, I know I can, let's see, multiply both sides by 2. Let me do this in red. Multiply both sides by 2 to cancel the fraction. This here, and the 2 there. Cancel the 2's. And divide both by -1. So I'm going to get root x over x squared equals 1. And if I multiply, I'm going to get x squared equals radical x. So what do I do here? X squared equals square root of x. When do those two equal each other? What can I do? Maybe I can square both sides. This thing that I did here? Alright, so I had... Okay, well, one way you could think about here, what I did is I multiplied both sides by 2 and I divided by -1 to cancel stuff, but another way you can think about it, maybe that's not the best sort of explanation, is basically what I can do is cross multiply. Right? I've got 2 fractions here, right? 2, 2. If I cross multiply, right, I've got 2x squared equal to negative 2x squared equal to -2 radical x. Right? Negative 2x squared times the negative 2x squared times the -1, and negative radical x times 2, and then I just cancel the -2 on both sides. So I've got x squared equals radical x. Basically what I did here is multiply both sides by x squared. X squared equal to the square root of x. When is that going to happen? Well, x equals 0 is a possibility. X equals 1 is a possibility. Is there some other number that's equal to the square root of the square root? I think those are it. How do I solve this, though? What we can do, let's see. If we square both sides, to get rid of the square root, I have x to the 4th power. X to the 4th power equals x. If I go x to the 4th, if I minus x on both sides, x to the 4th minus x equals 0. Now I have something I can solve. Factor out an x. I get x cubed minus 1 equals 0, and we have x times x minus 1, x squared plus x plus 1 equals 0. All right. So I feel like I've lost a lot of you. We're okay with everything up to the derivative here. Angel? Everyone? -1/2 x plus 2/3. Yeah, we're... Find the equation of a line that's tangent to the graph and parallel to the given graph. -1/2 plus 2/3. Yeah, we'll get that, Jessica. We'll get that. What we're doing here, right? We found this function, the derivative. Everyone okay with that? Thumbs up if you're okay with our derivative solving. We got this equation here for the f prime. Right? What we're doing now is we want to know where this x, at what x value is this derivative equal to the slope we wanted, which was -1/2. Right? The slope we found, the m we found, that we want to have is -1/2. Basically, f prime of x wants to equal -1/2. And we want to know what x value makes it so that this complicated looking equation equals -1/2. Right? Let me just double check that I'm doing this okay. So I set that equation equal to negative half. I set that equation equal to negative half. And this is the part where it gets complicated because we have this weird square root and we have this squared equation. Messy, messy equation. If I made this equal to 1/2, negative half, I cross multiplied, I got this x squared equals square root x. We're okay with that. Yeah? Is that okay, everyone? Thumbs up if you're okay with this, how we got this x squared equals square root x, right? We just made this equation equal to negative half. I cross multiply. All these tools we know how to use, we're just doing them like in this complicated way now, right? Cross multiply. Negative 2x squared equals negative 2 root x. Cancel the negative 2's. Divide by negative 2 on both sides. I get x squared equals radical x. Yeah? We're okay with that. Thumbs up if you're okay with this. X squared equals radical x. We got there. Fewer thumbs for that one. Should I go over this process again? How to get here? So what we did, let me see, can I select things and cancel? Oops, let's see if I grab this. Oh, look at that, beautiful. Let me try this process again. Whole problem again. Well, the first part was setting up our derivative, right? Plugging in the x plus h minus 1 over x, 1 over square root of x over h, multiplied by the conjugates. We got this part here. We did our fraction. We did the limit. Once we canceled our h's, we did our limit, getting rid of the h, and then we simplified, right? We added the bottom parts together. We had this x squared on the top here. I flipped and multiplied. I got this derivative here. Let me show you this last step again. Negative square root of x over 2x squared. I want that to be negative 1/2. Negative 1 over 2. Cross multiply, right? If we cross multiply, 2x squared times negative 1 is negative 2x squared. And then square root of x times 2, negative square root of x times 2. When you cross multiply, you get two equal things, negative 2 square root of x. Divide by negative 2, divide by negative 2. To cancel the negative 2's, I get x squared equals square root of x. Okay? What I did then is I have this x squared equals square root of x situation. I don't like my square root. I don't like having a square root in a problem. So I square both sides, and I got x to the 4th power equals x to the 4th power equals x. Because x squared squared is x to the 4th power, right? When you're solving these kind of quadratics, what you want is you want to make the problem equal 0. So I'm going to minus x on both sides. And I get x to the 4th minus x equals 0. The way you solve quadratics, or the way you solve polynomial equations, is you make it equal 0. Make it equal 0 and solve. Right? Then we can do things like factoring, we can do the zero product property, we can do all kinds of other stuff. Once you make it equal 0, polynomials, one of the things we talked, when we did polynomials way back in pre-calc or algebra 2, whenever it was, you made them always equal to 0 to solve them. Right? You do things like synthetic division or other kinds of strategies you have for solving these. But you want to make them equal 0. That gets you a way you can solve this by using factoring or other kinds of stuff. And now that we have it equal 0, I see there's some factoring I can do. I can take out a common factor of x. So I made this x times, I made this. This is x to the 4th minus x equals 0. I took out a GCF of x, became x times x cubed minus 1 equals 0. Right? Took out a GCF of x, made it x cubed minus 1 equals 0. Right? All right, now this x cubed minus 1, remember that a cubed minus b cubed we did before? Our factoring. The pattern for the cubed comes up again. Here it is. It's a minus b times a squared plus ab minus b squared. I hope you wrote that down somewhere, everybody. I hope you wrote this difference of cubes pattern somewhere in your notes so you can remember how to do this when it comes up. Because here's a cube, right? X cubed minus 1. 1 is a perfect cube. X cubed is a perfect cube. This is one of those perfect cube situations where you have to use this factoring where you break it apart. A cubed minus b cubed is a minus b, right? Keep it the same. Keep, change, square. Keep, square, change, multiply, square. Keep it simple. Calculus. I don't know. Keep the negative, right? You keep the a and the b, and my a in this case is x, and my b is 1. So when I factor this, I got x minus 1. That's this a minus b part, x minus 1. And then square the x, right? A squared, plus 1 times x is just x. It should be plus, always plus. Plus 1 squared is 1. So I have these situations here, this equation here. Okay? So I'm solving this. I'm looking for where x is equal to 0. And I've got, well, 3 kind of parts. This one doesn't really count. This is going to be imaginary. But this means x is equal to 0. This means x is equal to 1. And this means I can use quadratic formula to do this. And I'm going to get some imaginary zeros. That one doesn't work. But I have x equals 0 and x equals 1. 2 places on this 1 over x squared graph where the slope is going to be negative 1/2. Now that I have my x value, I can plug it in to find the point, the y value, right? 0, comma, well, that's not going to work, is it? What was my function? 1 over square root of x, right? Can my equation be a 0? Can I plug a 0 in here? 1 over square root 0? Is that going to work? No, right? So 0 is not allowed. Even though it's like an answer we got, it's called what was that word? It was I can't remember the word, everyone. It's a not allowed answer. It's anyway, I'll come up with the word, but it's not allowed, right? We can't use 0, right? 0 is not allowed because 1 over root 0, if we plug it in to find the graph, it doesn't exist. It's an extraneous solution. That's the word, extraneous. So equals 1 is my only one that's going to work, and that's 1 over, if I plug in 1 over square root of 1, that's going to be 1 comma 1. So here's my point, my x and y. My slope was negative 1/2, and I use those pieces to find my equation. Y equals negative 1/2 x plus b. If I plug a 1 in for y, plug a 1 in for x, I'm going to get 1 equals negative 1/2 plus b. Add the 1/2 to both sides. Add the 1/2 to both sides. B is equal to 3/2. So y equals negative 1/2 x plus 3/2, and that's where that comes from. Finding the b by finding the equation. So you found the point, you found the slope, you found the derivative. What was this? X. forgot what the derivative was. X squared root x, negative root x over 2x squared. Negative root x over 2x squared. If you didn't find the equation, this function here, as long as you found the point, the slope, and the derivative, that was okay. Feeling good, everybody? This is not what I'm going to make you do over the break, by the way. Nothing like this. This is probably the most complicated kind of situation you'll see. And I don't think this is going to be something that you'll have to do on the AP test. I do not think that they'll make it this complicated for you. The AP test is more testing your foundational knowledge. Do you know how to find a derivative? Right? Do you know, maybe you'll have to do one question where you'll have to multiply by conjugates. Maybe. Right? But it might be a multiple choice question. So if you know the rules, right? If you know these rules, it's going to become a little easier. But this is stretching yourself, everyone. This is stretching your abilities, bringing in all these different tools from all over. Right? See how far we can go. If you got lost on this, don't worry about it. It doesn't mean you're sunk. It just means if you know the foundational parts, if you know how to find a derivative, if you know what a derivative is, those are the things that are going to be most important on this test. If you can understand the concepts, the idea, if you understand what's happening, that's the part that's important, right? If you understand what this point means, what is this point 1, 1? Not necessarily how we found it. If you do get how we got here using all the square roots, that's fine. Zero product property, all that. But if you understand what this point is, that's like 90%. This location is where the slope of the tangent is 1/2 of this 1 over radical x function. That's what this means. And if you can understand that meaning, that's 90% of the problem. Okay? What this equation is the equation of the tangent line that touches this function at this point, 1, 1. If you understand the connection between these things, that's enough. That's enough. What this point means, this point is a location on this graph. This tangent line is the thing that touches it. If you can see that in your mind, right? Picture what that looks like. That's what you're going to be just fine.